What if I told you that while textbooks keep printing the Big Bang a settled history, the actual data coming from our most advanced telescopes has been quietly screaming that something is catastrophically wrong? We aren't just looking at minor adjustments anymore. We are looking at a crisis. The standard model of cosmology isn't just leaking, it might be sinking. And the alternatives? They aren't fringe theories anymore. They are mathematically robust, peer-reviewed challenges that suggest the universe is far stranger than a single explosion 13.8 billion years ago. The question isn't, is the theory perfect? The question is, do we need to start over? But before we continue, consider subscribing to the channel, liking the video, commenting down below, and sharing this with your favorite people. For the last few decades, we've relied on LCDM, the Lambda Cold Dark Matter model. It's the standard model of the Big Bang. It assumes the universe began in a hot, dense state, is expanding, and is filled with mysterious dark matter and dark energy. And for a long time, it worked. It fit the cosmic microwave background. It fit the distribution of galaxies. It was elegant. But here's where it gets fascinating. In the last 3 years, specifically from 2023 to 2025, the data has stopped cooperating. We have the Hubble tension, where the universe is expanding at different speeds depending on how you measure it. We have massive galaxies from the dawn of time that shouldn't exist. And most recently, we have evidence that dark energy itself might be weakening. Today, we are going to look at the cracks in the foundation. We're going to look at the 4.2 sigma signal that suggests our expansion model is broken. And then, we're going to look at the contenders, energy flow cosmology, and the hybrid CCC pulse TL model. These aren't just guesses. They are the new architecture for a universe we are only just beginning to understand.
Number 1.
The Hubble tension. If you measure the expansion rate of the universe based on its beginning, the cosmic microwave background, you get one number. If you measure it based on the local universe, using supernovae and pulsating stars, you get a different number, a significantly higher number. For years, astronomers thought this was just a measurement error. Calibrate the instruments, they said. Check the math. Well, they did, repeatedly. And the discrepancy didn't disappear. It got worse. The statistical chance of this being a fluke is now less than 1 in a million. That's not a rounding error. That's a signal that the model is missing something fundamental. But compare that to the bombshell that dropped recently. New galaxy map results have suggested that dark energy, the mysterious force pushing the universe apart, has weakened over the last 5 billion years. This comes with a statistical significance of 4.2 sigma. In physics, 5 sigma is the gold standard for a discovery. 4.2 is right on the doorstep. It implies that dark energy isn't a cosmological constant as Einstein and LCDM predicted. It's changing. It's dynamic. If dark energy isn't constant, then the standard Lambda CDM model is effectively dead in the water. It assumes a constant energy density. If that density varies, our entire timeline of the universe's future and its past needs to be rewritten. Think about what that implies. It means the big freeze might not happen. It means the expansion history we teach in universities is inconsistent with the reality we see in the telescope. That's not pessimism. That's a wake-up call.
Number 2.
The James Webb Space Telescope. When we launched JWST, the expectation was that we would see baby galaxies. Messy, small, irregular blobs just starting to pull themselves together from the primordial soup. That's not what we found. We found massive, bright, fully formed galaxies, existing mere hundreds of millions of years after the Big Bang. According to the standard model, there simply wasn't enough time for gravity to pull that much matter together. It's like walking into a nursery and finding a fully grown adult sitting in a crib. It shouldn't be there. Now, some recent high-resolution simulations suggest that maybe, if we squint and tweak the parameters, these galaxies can still fit into LCDM. They argue that star formation might be burstier than we thought, but that feels like a patch, not a solution. It's retrofitting the theory to save it from the observation. And it gets worse. We are seeing tests of large-scale isotropy, the idea that the universe looks the same in every direction, failing. Ellis-Baldwin-type analyses are hinting at a lopsided universe, a universe that flows in a preferred direction. The standard Big Bang model relies on the cosmological principle, that the universe is homogeneous and isotropic. If the universe is lopsided, the math of the Big Bang doesn't just get complicated, it stops working. This is where the contrarian cosmology step in, because if the standard model requires this many patches to survive, maybe we need a new engine entirely.
Number 3.
Energy flow cosmology, or EFC. This is a model that stops treating the universe as a container of stuff and starts treating it as a system of flow. In LCDM, dark matter and dark energy are placeholder terms for things we can't see but need to explain gravity and expansion. EFC reframes them entirely. It suggests that what we call dark matter and dark energy are actually phases of energy flow and entropy. Here is something thermodynamics taught us. Energy flows. It disperses. EFC proposes that the standard Big Bang model is actually just a zero-flow special case of a much broader reality. It claims to fit the cosmic microwave background data just as well as the standard model, but it does something the standard model can't. It eases the expansion tensions. How? By allowing for a varying speed of light. I know, that sounds like heresy. In standard physics, c is constant. But in EFC, the properties of the vacuum itself evolve. If the speed of light or the coupling constants of the universe change over billions of years, the impossible measurements we see today suddenly become possible. The tension disappears because the ruler we were using to measure the universe was changing length the whole time. That's not a small thing. It transforms the universe from a static geometric puzzle into a dynamic thermodynamic machine. It treats the cosmos not as a history of things, but as a history of processes.
Number 4.
The hybrid CCC plus TL model. This stands for covering coupling constants plus tired light. Tired light is an old idea. The theory that light loses energy as it travels through space, not because the universe is expanding, but simply because it travels such vast distances. For decades, this was dismissed. It didn't fit the data. But here's the twist. The new hybrid model combines this old idea with covariant coupling constants. Essentially, the idea that the fundamental strength of forces in the universe evolves. When you combine these two concepts, you get a model that fits the Pantheon plus Type Ia supernovae data, the very data used to prove dark energy, extremely well. It also fits the angular size of those impossible early galaxies found by JWST. In the standard Big Bang model, distant objects should appear larger than they are due to the expansion of space acting like a magnifying lens. We don't see that. We see small, compact galaxies. The CCC plus TL model predicts exactly what we see, and it remains consistent with the Planck CMB data within error margins. It is a serious, mathematical contender that solves the immaturity problem of the early universe by removing the need for an expanding universe to explain redshift entirely. Think about the audacity of that. It suggests the universe might not be expanding at all. It might just be evolving. We are at an inflection point. The data we have collected in just the last 3 years has done more to challenge the status quo than the previous 30 years combined. The 4.2 sigma signal of weakening dark energy, the impossible maturity of early galaxies, and the stubborn refusal of the Hubble tension to go away, these are not anomalies, they are evidence. Models like energy flow cosmology and CCC plus TL are moving from the fringe to the forefront because the standard explanation is running out of road. We might be witnessing the end of the Big Bang era and the beginning of something far more complex. If this surprised you, share this video. Because most people still think the science was settled in the 1990s. It wasn't. It is being rewritten right now. Subscribe if you want to follow how this unfolds, because as new data comes in from JWST and Euclid, every paper, every discovery, and every anomaly is going to matter. And we'll be covering all of it. The universe is speaking. The question is, are we brave enough to listen?